All right, here we go. We're going to look at another free response question that has been released for you to get ready for the upcoming semester exams. This question showed up on the last 2 years worth of exams. Let's see what we can do with this. Remember, before you watch this video, the expectation is that you spent 15 minutes on your own working through this problem, and now you're comparing your work to mine. When you're done, you're going to summarize your results, your findings, any mistakes that you made, and you'll turn those in. So here we go. We've got the graph of a differentiable function f is shown above in the interval -3 to 3. The graph of f has horizontal tangent lines at x equals -1, x equals 1, and x equals 2. And big F is the antiderivative of little f, that is, that big F prime is equal to f. Well, let's unpack that a little bit. We've got the graph of a differentiable function. Differentiable function means that the derivative exists and f is continuous. So both of those things are true. Derivative exists at all points and the graph is continuous. This may or may not be important later on. The graph of f has horizontal tangent lines at x equals -1, x equals 1, and x equals 2. If you have a horizontal tangent line, that means that your derivative is equal to 0. And I can see from my graph that at x equals -1, at x equals +1, and at x equals 2, if I were to draw in tangent lines, they would indeed be horizontal. Lastly, we know that big F is the antiderivative. Now that's a word we haven't used in a while, of little f. What that means is if I take the derivative of big F, I'm going to get little f. And just so that we're super clear, what we're looking at is the graph of little f. I want to make sure we don't get that confused. And we were told in the problem that little f is the derivative of the antiderivative big F. So here we go. Part A, find all values of x on the open interval -3 to 3 for which the function big F has a relative minimum. Well, if big F has a relative minimum, then the thing that we know is that big F's derivative, which is little f, must be changing from negative to positive. When my graph has a relative minimum, looks like that, or maybe looks like that, the function changes from decreasing to increasing, but the derivative, the slopes of the tangent lines, they are negative on this side, positive on that side. So let's look at the graph. Where does little f change from negative to positive? Or some of my students like to say, and I've really connected with this year, where does the graph of f change from being below the x-axis to above the x-axis? And that only happens at this one place over here at x equals 0. So x equals 0. You would be awarded 1 point for making the connection that big F has a relative min when big F prime changes from negative to positive, and a second point for identifying that happens at x equals 0, but at no other place on the graph. That's that for part A. Now let's look at part B. Part B, on what open intervals contained in -3 to 3 is the graph of big F decreasing and at the same time concave down? Decreasing and concave down, well, what does that mean? If big F is decreasing and concave down, then what that means is that the derivative of big F, little f, is negative and at the same time decreasing. So I have to look at the graph and I want to ask myself the question, where is little f negative below the x-axis and decreasing? Well, I can see that starts happening over here at x equals -2 and continues until we get to x equals -1. Now, I want to be really careful in my answer here. I need f to be strictly negative, so I am not going to include the -2, and I need the graph to be decreasing, so I'm going to say from -2 to -1 for sure, parentheses on the -2, and then depending on what your calculus teacher has told you, you would be allowed to say -2 to -1 open parentheses or -2 to -1 closed brackets. Either of those would be acceptable and you would get full points. In terms of awarding of points, 1 point for this connection, again, that between the behavior of big F and the behavior of little f, 1 point for identifying the interval, for a grand total of 2 points. Let's keep going. Part C. This is a doozy. I want to read this one twice. Assume that little f of 1.1 is equal to 2, and that big F of 1.1 is equal to -3. Use the tangent line to big F at x equals 1.1, estimate the value of big F of 1.3, then determine whether your estimate is an overestimate or an underestimate to the true value of big F of 1.3. Okay, one more time. Little f of 1.1 is equal to 2. This is telling me about a point on the graph of little f. Big F of 1.1 is -3, is telling me about a point on the graph of the antiderivative, big F. And what I want is an equation of the tangent line to big F at x equals 1.1. That's the first part. So let's take a look at that. Little f of 1.1 is equal to 2. Big F of 1.1 is equal to -3. I want the equation of, oops, you can't see that. I want the equation of the tangent line to big F at 1.1. Well, we always write the equation L of x equals your slope times x minus x1 plus y1. Now here's where we need to be careful. Both of these are expressed as points, but big F is the function that I'm interested in. Little f is the derivative of this function. So little f is the derivative. Little f is going to give us slope information. Big F tells us the point. So the graph I'm interested in passes through the point 1.1 comma -3, and the slope, big F prime of 1.1 is equal to 2. The equation of the tangent line, L of x, is going to be equal to 2 times x minus 1.1 minus 3. Now let's keep going. We were asked to approximate the value of big F of 1.3, and this is where we need to be careful. If I'm going to approximate the value of the antiderivative using the equation of the tangent line, then big F of 1.3 is approximately what I get when I evaluate my tangent line at 1.3. That is a perfectly acceptable answer. There's no need to simplify any more than that because these are all numbers. If you choose to simplify, that's okay, but your answer is going to have to be perfect. Otherwise, you're going to lose a point. For those of you that do simplify, 1.3 minus 1.1 is 0.2. 2 times 0.2 is 0.4, and 0.4 minus 3 is -2.6. So big F of 1.3 is approximately -2.6. Now, this last part is probably the trickiest part of this whole thing, and this is going to be a place where if you don't write your explanation perfectly, you're not going to get this last point. In order to determine if this value is an overestimate or an underestimate, what we need to do is we need to look at the concavity of big F. Now, by concavity, I'm talking about the way the graph is bending. If, for example, your graph is concave down and I make my tangent line, I can see that the tangent line is always above the graph. So if I use my tangent line to approximate the value of the function at a given point, the tangent line generates an overestimate to the true value. Similarly, if my graph was concave up and I were to draw in a tangent line anywhere, any tangent line that you draw will be below the graph, therefore you're going to generate an underestimate. Well, let's see what's going on here. I don't have the graph of big F to refer to. What I have is the graph of little f. So if I look on the graph of little f from 1.1 to 1.3, so basically like this little section over here, what we can say about little f is we can say from x equals 1.1 to x equals 1.3, I want to be careful. I want to know about the concavity of big F, but what I see is little f. The way that we're going to make this work is we're going to say that from x equals 1 to 1.3, little f is decreasing. And if little f is decreasing, then big F, the antiderivative, is concave down. If big F is concave down, like this graph over here, well, what do we know about the tangent lines? This means that the tangent lines are above the graph, which means that we are going to get an overestimate to the true value. In terms of how points would be awarded, 1 point for coming up with the equation of the tangent line, 1 point for coming up with the approximation, 1 point for this whole justification of overestimate for a really sort of standard but tricky 3-point question. It's especially this explanation over here where students aren't getting a perfectly correct answer. So you definitely want to go back, think about this one for a little bit. Make sure you mention the interval that contains the point of tangency and the point that we're estimating. Make sure you describe the behavior of the graph that you see, connect that to the function that we're actually talking about, and then tell me about the tangent lines. That's part C. Okay, part D, for the AB students, we're told that some new function, h of x, is equal to f of the sine of x, and we want to know if h is increasing or decreasing at h is equal to 0. Well, let me jot this down here. H of x is equal to f of the sine of x, and we want to know, is the graph of h increasing or decreasing at x is equal to 0? Well, how are you going to figure that out? I don't have the graph of h in front of me. I can't even really envision what that graph is going to look like. But what I do know is that the derivative of a function tells me about the behavior of the original function. So let's do this. Find the derivative of h. H is f of sine of x, so the derivative is going to be f prime of the sine of x times the derivative of sine of x, and the derivative of sine of x is cosine of x. Because we want to know if the graph of h is increasing or decreasing at x is equal to 0, we evaluate h prime of 0 to get f prime of the sine of 0 times the cosine of 0. The sine of 0 is equal to 0. The cosine of 0 is equal to 1. So we get f prime of 0. Well, what's f prime of 0? Good question. This is the graph of f. I don't know exactly what the value of the derivative of f is at x equals 0, but I do know that the graph of f is increasing, which means that f prime is greater than 0. And maybe you make a statement and you say, because f is increasing at x equals 0. Well, if h prime of 0 is positive, then that means h is increasing at x equals 0. Done. I believe when we scored this, we awarded 2 points for coming up with the correct derivative, 1 point for correctly evaluating h prime of 0, and then 1 point for the conclusion. That brings you to a total of 4 points. If you're an AB student,